You're in for a bit of a treat today with a masterclass from our fabulous team here at the ABS, starting with Sharon Fielder, who leads the Small Area Estimation and 2021 SEIFA team. Sharon's got more than 20 years of development and modelling of statistical product expertise. Her work leverages survey, administrative and census data, and she applies this in statistical modelling techniques. I'd like you to warmly welcome Sharon, who's going to take us through the presentation.
Thanks, Amelia. Before I begin, I'll just start with giving you an outline of what I'm going to cover in today's presentation. So I'm going to start with some SEIFA basics and then look at some examples that use SEIFA before I move on to showing you where to find SEIFA and what's included. I'll have a scenario of how to use SEIFA, and then, as Amelia said, we'll finish with the question and answer panel. So let's start with some SEIFA basics. Briefly, SEIFA, the Socio-economic Indexes for areas, is 3 measures: index scores, ranks, and quantiles, that's deciles and percentiles, also derived from the scores that categorise areas from lowest to highest relative advantage and disadvantage. SEIFA comprises 4 indexes created from Census, social and economic indicators. Each index aims to capture a slightly different aspect of relative advantage and disadvantage and is constructed using different indicators. IRSD, the Index of Relative Socio-economic Disadvantage, is a general measure of disadvantage only, and I'm just going to refer to this as the Disadvantage Index during this webinar. IRSAD, the Index of Relative Socio-economic Advantage and Disadvantage, is a general measure that includes both advantage and disadvantage measures, and I'm going to refer to this as IRSAD during this presentation. IER is the Index of Economic Resources, which focuses on financial aspects of advantage and disadvantage, and IEO is the Index of Education and Occupation, that's designed to reflect the educational and occupation level of communities. SEIFA data is available for 5 geographies, and that is statistical area level 1 and 2, local government areas, postal areas, and suburbs and localities. I'm just going to refer to statistical level 1 as SA1, LGAs and suburbs, just for ease of talking about these things. So advantage and disadvantage are very broad terms. For the purposes of SEIFA, we should be asking instead, what is socio-economic advantage and disadvantage? For SEIFA purposes, socio-economic advantage and disadvantage is defined as people's access to materials and social resources and their ability to participate in society. The Census of Population and Housing collects answers to a range of questions that gives us data on a lot of different topics. There are, of course, things that the census doesn't collect, and there isn't a question or a series of questions the census could ask that would let us directly determine whether a person or a household is advantaged or disadvantaged, especially as we would want this to be objective and consistent across the population. The questions we do ask on the census provide evidence we could use to decide if a person or a household is advantaged or disadvantaged compared to other people or households. The difficulty is in combining the results from all of them to get an overall indication of advantage and disadvantage, especially when we have indicators that might represent advantage and others that might represent disadvantage. From the census, we have data items available for income, education, employment, occupation, housing, family, dwellings, all sorts of things like that. We include in SEIFA everything from census that aligns with our definition of socio-economic advantage and disadvantage. What is available is constrained to what is collected on the census. This means that there are other indicators that could indicate advantage or disadvantage that are not included, not able to be included. These include indicators of wealth, housing affordability, and access to infrastructure. Since we don't have questions on the census about these, we can't add them in to see whether they would be indicators of our underlying concept of advantage and disadvantage. Now, health conditions were collected on the census for the first time in 2021, but they weren't included in SEIFA this time because health researchers need to look for relationships between health conditions and socioeconomic status, and that wouldn't be possible if we had included the health questions into the index. We're also sometimes asked about whether SEIFA is adjusted for age and Indigenous status. These are not included in the SEIFA because on their own, they aren't indicators of advantage or disadvantage. So that is, if you're 65 plus, that by itself doesn't represent either an advantage or a disadvantage, and some older people will be advantaged while others will be disadvantaged. We'll talk later about how SEIFA can be analysed alongside demographic data to investigate how socio-economic status and other measures not included in the SEIFA are related. So how are the scores for SEIFA calculated? SEIFA is constructed using a data-driven statistical method called principal components analysis. The most important indicators in the index are determined by the relationships in the data, not by subjective judgment. This method is applied to statistical area level 1 data, and all the indicators that go into SEIFA are proportions of the population within each SA1 based on census data. The principal components analysis gives us loadings that are used to create the indexes, and these loadings determine how much each indicator contributes to the final index score. Some SA1s don't receive SEIFA scores because they have low populations or low response rates for certain census variables, such as the number of employed people. We apply an exclusion rules framework that aims to obtain a reliable index score for as many areas as possible. This is why we don't calculate SEIFA at mesh block level, because we would likely need to exclude many mesh blocks in order to protect confidentiality. There are a couple of places you can find out more about how SEIFA is calculated, and I'll talk a bit more about that later. So what does the score mean? A lower score indicates that an area is relatively disadvantaged compared to an area with a higher score. For indexes that include advantage and disadvantage, a higher score means that the area is relatively advantaged, and a lower score means relatively disadvantaged. For the disadvantage only index, a high score means that it's relatively less disadvantaged, and a lower score means relatively more disadvantaged. Let's have a look at a couple of examples. Got Wollongong LGA has a disadvantage score of 1,000, while Arakan's score is 500. It would be the natural tendency to think this means that Wollongong is twice as advantaged as Arakan, right? Wrong. The index scores are on an arbitrary numerical scale, so they don't represent some quantity of advantage or disadvantage. All the scores can do is provide the means to rank the areas relative to each other. The scores should not be treated as numeric quantities. So what does the rank mean? To get the ranks, every area is ordered from the lowest to the highest score. The area with the lowest score is given a rank of 1, the most disadvantaged. The area with the second lowest score is given a rank of 2, and so on, up to the area with the highest score, which is given the highest rank, the most advantaged. For example, there's 565 LGAs in Australia that got LSAT scores, and to get the LGA ranks, we sort those LGAs from lowest to highest score. So the LGA with the lowest score would have rank 1, the next would have rank 2, and then the highest scored LGA would have a rank of 565. Then we also have state and territory ranks, and we follow the same process, but the starting point will just be sorting the areas that belong to that state or territory. Now, what do the deciles mean? To get the deciles, we start with ordering the list from the lowest to the highest score. The lowest 10% of areas are given decile number 1, the most disadvantaged. The next lowest 10% of areas are given decile number 2, and so on, up to the highest 10% of areas, which are given decile number 10, which is the most advantaged. This means that the areas are divided up into 10 equal size groups based on their scores. Percentiles are similar to deciles, except we divide the areas into 100 equal size groups instead. And likewise, quintiles are similar, but in that case, we're dividing them into 5 equal size groups. It's the same deal for state and territory specific deciles and percentiles. The starting point would just be the areas that are within each of those states or territories, and then we'd follow the same steps. So I said that statistical area level 1, SA1 is the base level for SEIFA, that's what it's created at. So how do we get the scores for the higher levels of geography? So here, if we look at an example, we have the local Beaumont, area of Beaumont in Western Australia, and according to Census Quick Stats, it's got a population of just over 42,000 people. We can see from the map that some of the Perth airport is within its boundary. Now, Belmont LGA is made up of 94 SA1s, each with its own SEIFA score. As you can see, we have an SA1 with no score, and we have SA1s belonging to a range of SEIFA quintiles. SA1 level index scores are standardised, so we can't just apply correspondence and add up the values to get an aggregate value. If we did add up all the scores, we can't take an average of the 94 areas either, because some of the areas might have a lot of people and some of them might not have very many at all. So we do have different population sizes that we need to consider. The indicators that go into creating the SEIFA are proportions of the population at SA1 level. So the best way to aggregate to the high level geographies is by taking the population size into account. So our best index score that we could derive for this LGA is a population weighted average. The technical paper section on constructing the indexes, which is step 11 of the step-by-step process, provides details on how we do this. So based on visual inspection of this LGA, it kind of looks like maybe quintile 2 makes up most of the regions, but let's have a look and see what quintile it actually ends up in. So here we have the Beaumont LGA, and we find that it's actually in quintile 3 and with a aggregate score of 987, and that's the best representation of relative disadvantage for this area overall. Keep in mind that the base level for SEIFA is SA1, not individuals. So the indexes represent the relative advantage and disadvantage of areas, not of people. Why is this important? Let's look at a couple of examples. Here is the suburb of Woodend North in Victoria. It has a SEIFA decile of 9, so we can say this suburb is relatively advantaged. There are 315 people in Woodend, but we can't say that they are all relatively advantaged because within Woodend North, there may be people who are relatively disadvantaged. This is the suburb of Merriwa, New South Wales. It has a decile of 2, and it's so we could say it's relatively disadvantaged. There are almost 2,000 people in Merriwa, but we can't say that they are all relatively disadvantaged because within Merriwa, there may be people who are relatively advantaged. So we need to keep in mind that it is an area-based measure. So that covers the basics of SEIFA. So I'm going to move on now and talk about some examples of research that show how useful SEIFA is. So this first example was a project investigating availability and placement of healthy foods and discretionary, that's less healthy foods, in supermarkets in Victoria that examined variation by area level socio-economic disadvantage. There's a snip of some results from the study, and they found that the average space that was used for less healthy foods was larger for relatively disadvantaged areas than it was for advantaged areas. The project used ERSAD at SA2 level, and they attached to their own data collection at the sample of supermarkets that they included. And in their conclusion, they talk about area-based and not individuals. And we can see that they're talking about the results being potentially useful for targeting low socioeconomic areas for further action. In this example, the aim was to investigate the link between socioeconomic status and breastfeeding rates using 3 ABS national health surveys. Here's a graph that was included in the paper that shows breastfeeding duration by numbers for the 3 health surveys. We can see that we have a line for the most advantaged areas and a line for the least advantaged areas. And we can see that there's a gap and it's getting wider as we go through each survey. Now, this project used the disadvantage index as well as other ABS data, and it focused on area-based analysis. So using SEIFA for this kind of project reveals how health outcomes differ between relatively advantaged and disadvantaged areas, which could lead to targeted programs to address that gap. In this last example, the aim was to look at the link between advantage and disadvantage and wildfire exposure to understand disaster risk. The results were presented as maps for Australia and also for Victoria, and this one for New South Wales, as they were the most affected. We can see that the map shows areas that have both high disadvantage and high hazard exposure, and areas that have both low disadvantage and low hazard exposure, and then all the areas in between. The project focuses on area-based analysis using the disadvantage index matched to other data, and the results focused on relative comparisons between the areas. So using SEIFA for this kind of research would assist in targeting the most vulnerable areas for the provision of appropriate services, for hazard education, for built environment improvements, for a range of things that would help with hazard risk. There are lots of examples of SEIFA in use. So just very briefly, a few other ones. There's a study on the relationship between socioeconomic status and hardcore smoking. It was used to see whether it could be useful in planning legal services by area. It was used in a study pre-COVID of childhood vaccinations, which looked at the privilege paradox of high socioeconomic areas having lower vaccination rates. And it was used to look at assessing vocational education training participation. So looking at these examples of how SEIFA was used in the past, we can see that SEIFA is good for geographic analysis, where the appropriate index is chosen to fit the research goals, where other data specific to the project is used in combination with SEIFA data, and when the goal was to find a connection between a topic of interest and relative advantage and disadvantage. Results from using SEIFA need to be relative comparisons between areas, and we saw that the results from this kind of work can be used to inform policy or planning targeted to where disadvantage leads to poorer results than for advantaged areas. That's just a sample of some of the ways that SEIFA has been used in the past. So now we'll move on and we'll have a look a bit about where SEIFA is and what's included. SEIFA has its own topic page on the ABS website. From there, you can access the data, methodology, technical paper, media release, and interactive maps. And we'll talk a bit about each of these in a moment. SEIFA variables are also included in Census Table Builder, in Data Explorer, on data by region, in ABS stat maps, and also there's some future plans with regard to SEIFA. So let's have a look at each of these in a bit more detail. The quickest way to find SEIFA on the ABS website is by searching for SEIFA 2021. Your search results will look something like this, and SEIFA was last updated on the 9th of May, so that would be the link that we would use. You'll notice there's also a separate link here to the technical paper so that you could access it from there if that's specifically what you were looking for. This is the SEIFA topic page, and we can see that we have the reference period based on 2021 data. We have some key results. Like every other ABS publication, there's some key statistics that are mentioned here, and I won't spoil those, so go and have a look if you haven't seen them already. From this page, we can find out a bit more about the indexes, what they are and what they're good for. The methodology page gives us the basics of SEIFA, very similar level to other methodology sections of ABS releases. Technical paper is a bit unique to SEIFA since there's a lot more detail that we can provide about how SEIFA is created, and you can access it again here also from this topic page. You can have a look at the media release, and we have our link to data downloads. You can also download all the data with the link at the top there. And we also have a section about the interactive maps, which provides a link and some instructions. The SEIFA methodology page should serve the needs of most users. It includes the basics of how SEIFA is constructed and information to enable users to understand the product. The ingredients for each index are provided, lists of indicators that contributed to the index scores. And if more detail is needed after reading through the methodology, the technical paper would be the next place to go. The technical paper is designed to provide you with everything you could want to know about SEIFA. It has a lot of information on every aspect of SEIFA, from conceptual frameworks to the data underpinning the indexes, construction, validation, and using and interpreting SEIFA. There's also an appendix with variable specifications and references for SEIFA and further reading. The interactive maps section has a link that will take you to the maps. There are also instructions on how to use the maps, and if you want more information about the geographic areas, there's some information there as well. Let's have a look at the interactive maps. This is the starting screen for the interactive SEIFA maps. We have all 4 indexes available to be viewed, and we're currently viewing URSAD. There are all 5 geographies available to be displayed, and this one is displaying local government area. We have quintiles denoting the least and most advantaged areas, color-coded so that we know on the map which ones we're looking at. We can zoom into the map if we want and reset to our starting point. We could type in some words for an area. We'll get a drop-down list to choose from, which will narrow down as we keep typing. If we select from there, it'll zoom to that area that we choose. We can return to the SEIFA publication from the map, and we also have some options under these dots here and on how to use the map. So the dots give us the ability to reduce the transparency so we can see the base layer. And the instructions tell us how we can make a particular geography level visible on the map. When we click on an area, we get information about its SEIFA variables and usual resident population. And if we click on zoom, then we get a more detailed view of that selected area. And this pop-up box from before also has at the bottom of it some links so that we can get some, go straight to quick stats for this area to see the census data. We can link back to the publication from here, and we can link to ASGS information from here as well. There's lots of useful map visualizations that you could do with the interactive map. I've used some of this already for this presentation to show the LGA boundary for an area, to show the SA1s that were within the boundary, and to show the underlying base level geography details for that area. Let's move on and look at data downloads. data analysis section of the SEIFA publication includes 3 types of data cubes: indexes, population distributions, and SA1 distributions. Let's look at what's in each. The indexes data cubes for the 5 geographies all have a contents sheet and an explanatory notes, a summary sheet that has the scores for all of the indexes together, scores and deciles, and a sheet for each of the indexes. These separate sheets have the scores, the areas rank, the decile and the percentiles, and they're provided at both national and state and territory level. This is what the index spreadsheet looks like. We can see that this is the sheet for the index of disadvantage for local government area. And we're looking at, if we look at our example from before, Belmont LGA, the spreadsheet gives us all the SEIFA numbers that we have available for this LGA. We can see, for example, that Belmont is in decile 6. It's not particularly more advantaged or disadvantaged than other LGAs. These index data cubes are the main output for SEIFA. The other data cubes are designed to assist in understanding and comparing SEIFA for the higher level geographies. The population distribution data cubes for these 5 geographies all have contents and explanatory notes as before, and then they have a separate sheet for each of the indexes that shows score ranges and then the percentage of people living in SA1s with scores in each of those ranges. I'll show an example in a moment. And that's provided for Australia and also for the region that you select. So the population distributions can be used to understand the diversity of the SA1 SEIFA scores within larger areas. If an area has a diverse range of SA1 scores, then the population will be spread widely across the scores. An area with a low level of diversity will have most of the population falling within a small range of scores. So here's an example of the population distribution data cube. We can see that we're looking at the disadvantage index, and we have a drop-down list available from which we can select a specific area. They're organised by state and then in alphabetic order. When we select from the list, the sheet updates. And so, for example, here we have Belmont, the data is for the Belmont, and the graph is also for Belmont. We also have the data for Australia as well. So this is included so that we can compare our region with the overall distribution for Australia. Scores are colour-coded. Red is the most disadvantaged decile, orange is deciles 2 to 9, and yellow is the most advantaged decile. Table has ranges of SEIFA scores from less than 500 all the way up to greater than 1,300. And the number of persons column for each range is the number of people living in SA1s with scores within this range. There is also an indication of the percentage of the population living in SA1s that didn't receive a score for this index. Remember that the index scores are not calculated for individuals, but for areas. So the tables and charts reflect the range of SA1 scores making up the population within an area. And lastly, the SA1 distribution data cubes for these 8 geographies. Again, they all have our contents and our explanatory notes and a separate sheet for each of the indexes. And that sheet includes the deciles and counts of SA1s for Australia. These data cubes can be used to understand the diverse range of the SA1 SEIFA scores within larger areas. If an area has a diverse range, then the SA1s will be spread widely across the 10 deciles. An area with a low level of diversity will have most of the SA1s falling within a small range of deciles. Here's an example of an SA1 distribution data cube. We can see that we're looking at the disadvantage index and we're looking at LGA. We have our counts for decile 1 through to decile 10 that show how many SA1s are in each of these deciles. We have the decile for LGA also included so that you can compare the overall decile with the spread of SA1 deciles. And lastly, we have a count of the SA1s that have the score and a score and the number that don't. So that allows us to get an indication of how much the LGA is covered by the LGA score and decile. So that's our data cubes that were provided as part of the main SEIFA publication. SEIFA is also in Census Table Builder. The SEIFA variables are included here as this allows users to analyse SEIFA against other census characteristics and look for relationships between advantage and disadvantage and these characteristics. From the ABS homepage, you can get access to Table Builder, and from there, select Table Builder, and you'll need to log into your Table Builder account. Once there, you'll find SEIFA under the 2021 Census of Population and Housing tab for Census Table Builder Pro, and it's the counting person's place of usual residence. We have SEIFA deciles available for inclusion in tables along with other census data items. There are 2 versions, the area-based deciles and population-based deciles. Area-based should be used for most purposes because SEIFA has been designed to be an area-based measure. And I'll talk about population-based in a moment. If the geography is to be included in a table for SEIFA, make sure to choose the deciles that match. If we want a table of LGA, we shouldn't use the SA1 deciles. Instead, we would use the LGA SEIFA deciles. You'd still get data, but it would be wrong because SEIFA deciles are specific to each geography. If you're interested in advantage and disadvantage by itself without a geography focus, then use the SA1 level SEIFA deciles. Lastly, when putting SEIFA deciles into a table with other census variables, don't include variables that are part of SEIFA. So age is okay, gender is okay, but we wouldn't put occupation in there or employment because those indicators have been used in SEIFA. If you did include them, the results could be misleading because these variables have influenced the SEIFA results. Now, some words about population-based deciles. So area-based and population-based deciles, they're two different measures and they have different uses in analysis. Area-based deciles are easy to interpret because SEIFA is designed and constructed as an area-based measure. So we recommend area-based deciles for general use. Population-based deciles are calculated by dividing SEIFA areas into 10 equal groups in such a way that the population of each group is approximately equal. The population in the most disadvantaged decile is the 10% of the population living in the most advantaged areas. It's not the disadvantaged 10% of the population. So population-based deciles can be difficult to interpret, and because it's an area-based measure, as I said, there can be some clumping in the population. So the population-based deciles will not always be exactly a tenth of the population. If you require assistance with Table Builder, we have resources on the ABS website to assist with getting started and getting some help to use it. And there's also a video on the ABS YouTube channel as well that could help you get started. SEIFA is also in Data Explorer. This allows users to customize the data cubes to example, include a selection of regions or only some of the SEIFA variables. Data Explorer also has APIs available for use so that SEIFA data can be accessed by other software for easier extraction and inclusion with other user data. You can get to the Data Explorer data for SEIFA from the bottom of the data cube section. There's a link there. And that will take you straight to the Data Explorer data for SEIFA. But if you're coming in from the main screen of Data Explorer, don't look for it under Census because it's actually in snapshots, and there's a link there to the 2021 census data. So what we have available within Data Explorer, there is data for 2011 and 2016 and the newly loaded 2021 data. These are all of the geographies that are available for SEIFA, so for each census year. So in total, there's 16 data sets in Data Explorer. For the 2021 data set, all 11 SEIFA variables are included for all 4 indexes, except for the last 2, which aren't available, obviously, for the SA1 level indexes. So an example of a Data Explorer table, this is really just to show you that you can see that there's the customize capability and we have the APIs. If you want some help with Data Explorer, the guide on the ABS website provides information about getting started and getting help, and there's a link in the SEIFA publication that will take you directly to this page. SEIFA data has been added to Data by Region as of the latest update of that product last week. Data by Region is a one-stop shop for regional data, including census, other ABS and non-ABS data. So including advantage and disadvantage adds value to forming a picture for each region. You can access Data by Region from the homepage of the ABS website, and from the interface, you can select a region by drilling down, or you can search for a specific region by name or code that provide the region that you've selected, and then you can view the data through the link that pops up there. The Data by Region is organised into themes, and SEIFA belongs to the family and community theme. It includes deciles for all 4 of the indexes, and we have Australia and state and territory level. And you can download data for your region, which will include everything in a theme from in Excel format or in CSV format as well. SEIFA is an ABS stat maps. And releasing SEIFA as a web service enables users to pull geospatially enabled SEIFA data directly into GIS software, web apps, and platforms. This saves time and provides confidence that data is spatially linked to the latest ASGS version and that the metadata is accurate. Where to find SEIFA in the ABS StatMaps? SEIFA is part of the numerous public web services available on our new ABS StatMaps ArcGIS Enterprise platform. SEIFA for suburbs and localities is featured on the home screen, but if you search for SEIFA, you'll find all 5 geographies available there. SEIFA web services are 100% public and they're ready to use right now. In the future, SEIFA data will also make its way into other data sources. For example, the survey microdata files, as they get released, will include SEIFA variables. There's also some potential work we may do over the next few months to investigate if there is a need for a health-focused SEIFA index that would use those new health conditions questions collected on the 2021 census. And we're also potentially looking at whether there's a need for a 2021 version of the Index of Advantage, of Household Advantage and Disadvantage, which was published as an experimental product for 2016. So we've now covered where to find SEIFA and what is included. Now, how you use SEIFA depends quite a bit on the analysis or research it's being included in, so we don't have a one-size-fits-all how-to guide. Instead, let's look at a scenario and see how SEIFA can be used and what to look out for. This will give you some tips and incorporate what we've learned about SEIFA today. We'll use a very simple scenario. Suppose Charles Sturt local government area has been given a grant for improvements within their region to help those who need it the most. Let's ignore the local knowledge staff at the LGA would likely have, because any decisions they make will need an evidence base to justify them. The question is, where should they put the money so that they get the best outcome for the most people within the region? Some questions that seem relevant to start with are, what level of advantage and disadvantage is there? How variable is the advantage and disadvantage? And what factors are influencing advantage and disadvantage? That sounds like a job for SEIFA. Let's start with deciding what index we should use. This section of the SEIFA topic page provides some broad guidelines to assist in picking an index. The index should be chosen based on the type of analysis being undertaken. In our scenario, we're funding for improvements, and it doesn't say we're looking for just disadvantage, so ERSAD would be a good choice. So we can offset disadvantages with advantages. So I think we'll choose that, and we'll go onwards and have a look at the index data. So the index spreadsheet for Charles Sturt LGA, we can see some results here, all of the SEIFA variables. So the score is 903. Is that good? We don't really know. By itself, the score is meaningless. The rank for Charles Sturt is 408. Now, since I know there are 565 LGAs in Australia, I'm starting to get a feel for the area. It's one of the relatively more advantaged LGAs in Australia. The decile for Charles Sturt is 8. So again, that's confirming it's amongst the highest end of LGAs, but there are 20% of LGAs that are relatively more advantaged than Charles Sturt. For all the SA1s in Charles Sturt, the maximum score is 1,111 and the minimum is 678. That's quite a range, and the lower score might be a relatively disadvantaged part of the LGA. And we also could see from there how many LGAs were included and their scores for all the people that live in LGA of Charles Sturt. So if we turn our attention to the SA1 distribution data cube, see what we can learn about the diversity of SA1 scores. So the region has quite a diverse range within it. There's quite a few SA1s in SEIFA deciles 1 and 2. The middle range, they all have around the same number of SA1s, and at the upper end we have a smaller number with decile 9 and no SA1s that are in decile 10. So if we just did a uniform spread of funding throughout the region, we would cover residents living in both advantaged and disadvantaged SA1s, which is probably not what we would want. Let's just have a look now at the population distribution and see what we can learn from that. Populations living in SA1s with each of the SEIFA score ranges looks quite a bit different from the Australia picture. We have a high proportion of people living in SA1s with scores in the 2nd to the 9th decile. Approximately 3% of people live in SA1s with scores in the lowest decile, and no one lives in SA1s with scores in the highest decile. And as I said, the population distribution is quite different from Australia overall. This shows us that if we want to target people living in the most disadvantaged SA1s, we can't just give funding to every part of the region. While we now know that Charles Sturt LGA is relatively advantaged, we don't know why. The SEIFA data cubes can't tell us that. To find out more, we need to know what indicators are important for ERSAD. We can use this knowledge while looking at census data to see if we can work out why Charles Sturt is relatively advantaged. If we head over to the SEIFA methodology page on the ABS website, we can get a list of the advantage and disadvantage indicators included in ERSAD. High income is the strongest indicator advantage. Some occupations, qualifications, and dwelling characteristics are also indicators of advantage. No Year 12 or higher is the strongest indicator of disadvantage. We have low income, some qualifications, quite a few employment variables, dwelling and family characteristics that are also indicators of disadvantage. So now we know what to look for indicators of advantage and disadvantage. Let's have a look at census data for Charles Sturt LGA. We can access the quick stats from the interactive map, as I said before, or also from following this path from the ABS homepage. So I scrolled through all the quick stats data for Charles Sturt, looking for advantages that stood out as either being better or worse than the state or national values. We're not trying to reconstruct the ERSAD score here, and the quick stat variables aren't exactly the same as what's in SEIFA. We're just trying to get a better understanding of the area in terms of the things that make it relatively advantaged. The percentage attending uni is higher for Charles Sturt, which adds to relative advantage. The percentage of dwellings with 4+ bedrooms is lower, it's taking away from relative advantage. The percentage of households with high income is higher, and the median income for this region is higher as well, so that adds to the relative advantage. So I did the same thing for the disadvantages, noting any that stood out as either being better or worse than for the state or national values. For this one, I found that the percentage of people with Year 11 or Year 10 as their highest educational attainment is lower, taking away from relative disadvantage, but the percentage with no educational attainment is higher, adding to relative disadvantage. Unemployment is lower, so that takes away from relative disadvantage. And the percentage of families with kids where both parents are unemployed is lower, also taking away from disadvantage. And then finally, the percentage of households with low rent is higher, which adds to relative disadvantage. What this tells us about Charles Sturt is that there is no one category of advantage or disadvantage we could target for action. Collectively, quite a few indicators are combining to result in this LGA being relatively advantaged. The goal is to provide funding to the parts of Charles Sturt LGA that need it the most. Let's have a look at where these areas are located so we can work out which suburbs to target. This is the Charles Sturt LGA using our interactive SEIFA ERSAD map. With suburbs visible, we can see that there are some relatively advantaged and relatively disadvantaged suburbs in this LGA. We have some suburbs in quintile 5, the most advantaged, and some in quintile 1, the most disadvantaged. Let's find out a bit more about these suburbs. We can use the interactive map to identify which suburbs within Charles Sturt LGA are relatively advantaged. Clicking on the darkest blue regions, that's quintile, the most advantaged, we can see we have St Clair, Grange, Tennyson, Bowden, Henley Beach, and Henley Beach South, as are all being in the most advantaged quintile. 4 of these are in decile 9 and 2 are in decile 10. These areas collectively account for about 17% of the population of Charles Sturt LGA. Doing the same thing for the disadvantaged areas, we can see that we have Pennington and Woodville North are both in the most disadvantaged quintile, both in decile 2. These 2 regions account for about 5% of the population living in Charles Sturt LGA. Now we should return to quick stats next and find out a bit more about what's driving disadvantage in both of these suburbs, but I won't cover that because it's the same idea as what we've just done previously for the whole LGA. So we now know that Charles Sturt is relatively advantaged, but there are areas that are more advantaged. There's no one thing that stands out as the reason why the area is advantaged. The disadvantaged factors that contribute are fewer large and more low rent homes. The advantage factors that contribute are low unemployment and high income, uni attendance and educational attainment. Woodville North and Pennington are the most disadvantaged suburbs, so if you have limited fundings, we should put it there, and not in Henley Beach, Grange, Tennyson or Bowden, which are the most advantaged suburbs. Of course, there are other suburbs in Charles Sturt that are also relatively disadvantaged, so we do more work looking beyond just these 2 most advantaged suburbs. There are probably other factors not related to SEIFA that should be taken into account too. This scenario serves to show how SEIFA has a place in this type of investigation. It's natural to wonder whether these suburbs have always been disadvantaged, and since there's been a SEIFA produced for each census since 1971, we could easily look it up and see how things have changed, but I didn't do that. Why? We don't recommend using SEIFA for longitudinal analysis. SEIFA is a snapshot. It's not designed to measure change over time. If an area has a different SEIFA rank or decile from one census to the next, it can be difficult to interpret why this is. It could be because there has been a genuine increase or decrease in disadvantage, but that's not the only reason an area's SEIFA score will change from census to census. Geographic boundaries change, which might result in an area that is different enough we shouldn't compare it. The number of areas in a geography level might change. The population characteristics might change. For example, there's an SA1 in Victoria where the median age went from about mid-30s up to 80s between 2016 and 2021 because a large retirement establishment was built there. The census questions might change so that the indicators we use in SEIFA aren't the same as they were before. And some indicators we used might not be available anymore, like no internet. So that might result in an impact on an area's SEIFA result. SEIFA scores are created from a statistical process. The more important indicators might vary from last time, and the weights each indicator gets might also change. Or the distribution of scores might change. It's hard to understand how we should take this into account when comparing census years. And we would need to understand all of these potential changes before we could confidently compare SEIFA over time. So instead, we should compare census data for SEIFA indicators. And if you must compare SEIFA, please use the ranks and quantiles and not the scores. So that completes the scenario that I wanted to present today.